Okay, so hi guys, I'm Rob Doverne. I'm one of four directors of Foley Group Architecture. We're a company based here in Christchurch. We work all around New Zealand. We have a team of architects. We also have interior designers and landscape architects as well, so we offer the whole service. We've been involved in Superhome for over 10 years now, and it's something that we are really passionate about. It's not everything that we do, but it is something that we do encourage all of our clients to think about if they can. Not everybody can go the whole hog and do a full-blown super home or a passive house, but there are a lot of really good things that you can do to lift it above code minimum and get a lot of bang for your buck. So we're here in a home that I recently built for my family in Cashmere on Port Hills in Christchurch. We just love the area, we love the views, we love getting above the fog layer in Christchurch as well. So this was a place that we really wanted to come and settle down. So it was a long-term investment for us, which helped us justify going a little bit above and beyond with the investment in the build. It was a tricky time to build. It was shortly after COVID when we did have a lot of challenges around supply and pricing constantly moving. So it was really hard to keep those sustainability and performance ideals in place. Well, we navigated that, but it's something that's very important to us. So it's something that we stuck to, and we're really pleased that we did, because the end result is fantastic. We've been here 3 years now. And last year, 2024, this house won the Super Home of the Year, which was just a fantastic endorsement for us. It's not something that we had attempted or that we had tried to do, but it's something that was just a really positive reinforcement. So in designing this home, we obviously stuck to the core principles of Superhome and performance design, but along the way too, there are a number of times where we pushed and even broke the rules or what's ideal. We have a beautiful skylight in the ceiling that's obviously a great big hole in the thermal envelope, but it does let a beautiful amount of light in and some of that solar gain as well. And we did do a lot of testing around the effect of that. So knowing what the effect of those changes are is really important. Once you know the rules, you know how you can break them, and you know what the effect is going to be. We've also got a ultra low emission wood burner in our lounge. It's not really needed for space heating because it's obviously quite a high performance home as it is, but we do have a plentiful supply of firewood on the property, which we replace with natives as we use it, and so that's just something that we're able to do here too, and something that we love. Anything and everything, trying to be location specific, so plants that would have been here originally or grow naturally here, because plants that are endemic to the area do a lot better. They don't need watering, and they're more frost resistant, although we don't really get frosts up here. And we're also trying to use plants that attract bird life. So there are tuis, wood pigeons, bellbirds around the place as well. So we're looking at plants, native plants that they would naturally use as food sources. Try to get some of those going as well. Okay, so while we did break a few of the rules, there are a few non-negotiables that we absolutely stuck to. One of the keys is double layer of framing. So we have 90mm framing, which is standard building code, but inside that we have another line of 45mm framing that runs counter to the studs, and that is also insulated. So that secondary insulation layer bridges all of those studs and really lifts the thermal performance a lot more than just increasing the wall thickness. Those studs don't need any dwangs because we use structural cavity battens on the outside for cladding fixings, and that further reduces thermal bridging and increases the amount of insulation in the wall. Also the windows, they're a standard thermally broken low E and argon aluminium joinery, which is quite common now, but what we did differently is we recessed that into that thermal envelope. We've set them back and used flashings to maintain code compliance, but just by recessing them into the envelope increases their performance by about 20%. So we don't get any condensation on the inside of these windows, we actually get condensation on the outside on a really cold day. As well as that, we've got a mechanical ventilation system with heat recovery through the whole home. That's running constantly in the background, and so that's constantly bringing in fresh air and tempering that fresh air with the outgoing warm, stale air. Sure. Yeah, so air tightness is something that is often held up as quite an important thing in high performance design, and it is really good. But we also have a young family and a lot of animals, so a lot of in and out. Have to have a cat flap in the house. That's not particularly airtight. So yeah, that's another area where we probably broke the rules a little bit, but it suits our family and our lifestyle, and because we did everything else right, it's not doesn't have the major effect that it would do if you hadn't insulated as well. Yeah, that's right. You can get airtight cat flaps, but they're pretty. I did look into them, but they're pretty full on, pretty expensive. Yeah. So, but we did try and locate things like the cat flap downstairs in the laundry door, so the cat and the dog come and go through the back door of the garage, and then through a cat flap in the laundry. So there's like a series of airlocks, if you like. So it has less of an impact than having if we were to have a cat flap, say in the door through here into the kitchen, which would have been a little bit easier for the cat. So yeah, she has learned to live with that. I don't think you really need to be too careful when you're talking about it. I think most people realise now that the code is a minimum standard. It's not something that should be considered a target or something to be aimed for or something to advertise that you've met, because it really is just an absolute minimum baseline. So we didn't really consider that part of the code. Certainly other parts of the code like weather tightness, structure, that's really important, and there's not really a need to go above and beyond that, although building a more seismically resilient building and future-proofing your design, that's a great way you can go above code. But in terms of thermal performance, certainly don't use the building code as a target or a standard. If you are designing well and doing thermal modelling, then you don't even have to worry about it. You're so far past code minimum. Another tricky part about the building code that a lot of people aren't aware of or don't realise is that the different clauses, while they deal with different aspects of a building, are all interrelated in that changing one thing has an effect on other things. Increasing insulation has an effect on moisture build-up in the envelope, and building more airtight and more weather-tight has problems with ventilation. So you really can't change one thing without looking at the whole. And I think that's where we've got into trouble with the building code over the years, is that we've made progress and changes in some areas, but it hasn't been balanced. So a big area of concern now is the build-up of moisture inside the building envelope, and yeah, I think we really need to do something about that quite urgently. It's not about lifting the standards further. It's about addressing a real shortcoming and a danger, a health danger, but also a danger in terms of the effect on buildings long term. We've been seeing a lot of code compliant homes with really high levels of moisture, especially in the roof cavity, and that's an effect of building standards improving, building materials improving, and becoming a lot more with a focus on weather tightness due to the leaky homes saga and things like that. So we're building a lot better into a much tighter tolerances, but that means there's just not the gaps that would traditionally have allowed air movement through and allowed that moisture to move out and dry out. So yeah, by building more airtight naturally, which is a good thing, and also in terms of the way we live, we're warming our homes a lot more, which is a great thing. But also we do tend to, a lot of people tend to have two working partners. So get up in the morning, have a shower, leave for work, but the house is usually shut up for the day. So all of that moisture that's built up overnight isn't being dealt with during the day, and that's migrating through the walls and through the ceiling, and then condensing on those cold surfaces where those external surfaces meet the cold outside air. That's called the dew point, and if that's not carefully considered, then that moisture builds up there, and if it's not dealt with, if it's not dried out through good ventilation, then it just builds up and builds up and builds up over time, and then that forms mould, creates a perfect environment for mould to grow. So my company, Foley Group, we work across quite a wide range of sectors and typologies, from bespoke homes like this, right through to high density residential developments, aged care and commercial work. So yeah, we see the full spectrum, and some of that, yes, is code minimum, and some of it is high performance. So we do work with the client from their initial briefing stage to establish what their budget is and what their target is, and find a way to basically get the best for them, fit for purpose, but also to budget, and with a view to the long-term value of their asset. I think New Zealanders are still a little bit trapped in trying to reduce their upfront cost as much as possible, and they're still thinking short term. So most New Zealanders are thinking around 7 years, and then they're looking to flip, sell the house and move on. We don't think like Europeans and other cultures do, where we might be in the same house for literally generations. If we started thinking that the home that we build is going to be our children's home and our grandchildren's home, then that would immediately change our approach to building. But most people are thinking about it as just an asset, just something to invest in and then flip. And when you're doing that, yeah, you're trying to reduce cost as much as possible, and the things that you choose to spend money on might be the flashy things that are going to appeal to a potential buyer, not so much the things that you can't see, like air tightness membranes or insulation. One of the issues with our building code and our approach to building is that it's retrospective. We're looking at the things that we're seeing now, which are the effects of the climate that we're in now, but the climate as it has been, and we're not really looking forward, we're not looking ahead. And as you say, the climate is changing rapidly, and really what we should be doing is designing and building not for the climate as it is now, but as it's going to be in 20, 50, 100 years, because the homes that we're building are still going to be around, and they're still going to have to be able to cope with that and be able to be adapted to suit that. So definitely, I think that's something that we should be looking at a lot more. Yeah. There's other ways that you can think about future-proofing too, in terms of just make a flexible design so that it can suit people as they age, for example. Building in accessible features or the ability to easily retrofit them means that you can stay in the home a lot longer and you're not forced out because of accessibility issues. With future-proofing, it means you don't have to build everything into the home straight away. For example, in this house, we weren't able to put in heat pump hot water at the time. So what we did do is that we pre-piped for the heat pump unit and we put in a hot water cylinder that would cope with having a heat pump system added onto that. And we've also pre-wired for solar panels. So there are things like that as long as, and those were small upfront costs, but it will make it easy for us to add those things on as we're able to down the track. So for me, a big part of good design is site selection. A lot of people don't have a lot of control or choice about where they're building. So we were very fortunate that we were able to pick up this amazing site with these great views, which also has its challenges. It does force you to design a certain way, and it forces some responses in terms of the orientation of the home, making the most of these views. You don't want to compromise on those things just for better thermal performance. So picking the right site that allows you to design with those things in mind is really key from the start. So I would say if you are looking at a site or if you're wanting to design, then getting your designer involved at the point of site selection is something that would be really helpful, because it can set you up for what you can do with it.